What if the key to unlocking the mysteries of deep space isn't a single, massive spacecraft, but a fleet of tiny, self-coordinating drones working together like a swarm of bees? This isn't the plot of a sci-fi blockbuster, it's the cutting edge of space exploration. Today, we're diving into the revolutionary world of swarm drones for deep space missions, where these autonomous systems are set to redefine how we explore the cosmos. From their advanced artificial intelligence to their ability to adapt and problem solve in real time, swarm drones are poised to become the ultimate tool for uncovering the secrets of the universe. Whether you're a space enthusiast or just curious about the future of technology, this journey will challenge what you thought was possible and reveal how these tiny explorers could shape the next chapter of humanity's quest to understand the stars. Let's take a closer look at how swarm drones are transforming the way we think about deep space exploration. Imagine a fleet of tiny robotic explorers, each no larger than a shoebox, working together as a single, intelligent unit. This is the essence of swarm drones, a revolutionary concept in space exploration. Unlike traditional spacecraft, which rely on a single, highly complex machine to carry out missions, swarm drones operate as a collective. They're designed to mimic the behavior of natural swarms, like flocks of birds or colonies of ants, where each individual contributes to the overall success of the group. What makes swarm drones truly remarkable is their ability to collaborate seamlessly. Each drone is equipped with advanced artificial intelligence, allowing it to process information, communicate with its peers, and adapt to changing conditions in real time. If one drone encounters an obstacle or detects something unusual, it instantly shares that data with the rest of the swarm. This collective intelligence enables the group to solve problems and complete tasks far beyond the capabilities of a single spacecraft. For example, in the vast, uncharted regions of deep space, swarm drones could map asteroid fields, analyze atmospheric conditions on distant planets, or even search for signs of life, all while navigating environments too hazardous for traditional probes. Their compact size also makes them cost-effective, as launching multiple small drones is often more practical than deploying a single, massive spacecraft. This innovative approach isn't just about efficiency, it's about reimagining how we explore the cosmos. By harnessing the power of swarm intelligence, we're unlocking new possibilities for discovery, pushing the boundaries of what's possible in space exploration. The future of deep space missions might not rest on the shoulders of one giant leap, but on the synchronized steps of countless tiny explorers. The journey of space exploration has been nothing short of extraordinary. It all began with the launch of the first satellite, Sputnik 1, in 1957, a tiny beeping sphere that marked humanity's first step beyond Earth. From there, we sent astronauts to the moon, deployed robotic probes to distant planets, and even landed rovers on Mars. Each milestone was a testament to our relentless drive to push boundaries and explore the unknown. Yet, as impressive as these achievements are, they also reveal the limitations of traditional spacecraft. Think about it, most of these missions rely on single, large, and often incredibly expensive vehicles. These spacecraft are designed for specific tasks, and once they're launched, there's little room for adjustment. If something goes wrong or if an unexpected opportunity arises, like discovering a new geological feature on Mars, the mission can't easily adapt. That's where swarm drones come in, offering a revolutionary shift in how we approach space exploration. Swarm drones are not just a single tool, but a network of smaller, interconnected units that work together. They're like a team of explorers, each contributing unique skills and perspectives to solve a problem. This flexibility allows them to tackle challenges that would stump a traditional spacecraft. For example, if one drone fails, the others can compensate, ensuring the mission continues without interruption. They can also split up to cover more ground or come together to analyze a complex phenomenon from multiple angles. But what makes swarm drones truly groundbreaking is how they fit into the larger story of space exploration. They're not just another piece of technology, they're a reflection of our evolving approach to discovery. Just as early telescopes gave us our first glimpse of the stars and rovers brought distant planets within reach, swarm drones represent the next chapter in this ongoing saga. They embody the same spirit of innovation that has always driven us to explore, but with a modern twist, the ability to adapt, learn, and overcome the unpredictable challenges of deep space. By looking back at how far we've come, it's clear that swarm drones aren't just a step forward, they're a leap into a new era of exploration. They remind us that every technological breakthrough builds on the lessons of the past, while opening doors to possibilities we've only just begun to imagine. When we think about space exploration, the image that often comes to mind is a single, massive spacecraft, meticulously engineered for a specific purpose. These traditional spacecraft are marvels of human ingenuity, but they come with significant limitations. They're expensive to build, difficult to adapt once launched, and often carry the weight of an all-or-nothing mission. If something goes wrong, the entire mission could be at risk. Enter swarm drones, a revolutionary shift in how we approach space exploration. Unlike their monolithic counterparts, swarm drones are small, modular, and designed to work together as a cohesive unit. The beauty of swarm drones lies in their flexibility. Instead of relying on one spacecraft to do everything, a swarm of drones can distribute tasks among themselves. Imagine a team of explorers where each member has a unique skill set, collaborating to solve problems in real time. For example, while one drone maps the surface of an asteroid, another could analyze its composition, and a third might search for potential landing sites. This division of labor not only speeds up the process but also reduces the risk of mission failure. If one drone encounters an issue, the others can adjust and carry on. Communication is another game changer. Swarm drones are equipped with advanced systems that allow them to share data and coordinate actions seamlessly. This means they can adapt to unexpected challenges, like navigating through a dense asteroid field or responding to sudden changes in a planet's atmosphere. Traditional spacecraft, on the other hand, are often limited by pre-programmed commands and slower communication with Earth. Swarm drones, in contrast, operate like a well-oiled team, making decisions on the fly and maximizing efficiency. Cost is another area where swarm drones shine. Building and launching a single traditional spacecraft can cost billions of dollars, but swarm drones are far more economical. Their smaller size and modular design mean they can be mass-produced and launched in groups, spreading out the financial burden. This opens the door for more frequent missions and a wider range of exploratory opportunities. Instead of waiting years for one high-stakes mission, we could deploy swarms to multiple locations, gathering data and expanding our understanding of the cosmos at an unprecedented pace. Perhaps the most exciting advantage of swarm drones is their adaptability. Traditional spacecraft are often designed with a single mission in mind, like landing on Mars or studying a comet. Swarm drones, however, can be reprogrammed and repurposed for a variety of tasks. A swarm sent to explore Europa, one of Jupiter's moons, could initially focus on mapping its icy surface, then shift to searching for signs of microbial life beneath the ice. This versatility makes swarm drones an incredibly powerful tool for tackling the unknown challenges of deep space. In essence, swarm drones represent a paradigm shift in space exploration. They're not just smaller versions of traditional spacecraft, they're a fundamentally different approach. one that prioritizes collaboration, adaptability, and cost efficiency. By leveraging the collective power of these tiny explorers, we're opening up new possibilities for uncovering the mysteries of the universe. At the core of every swarm drone system is artificial intelligence, a technology that transforms these machines from simple tools into intelligent, adaptive explorers. Picture a fleet of drones navigating the vast emptiness of space, each one processing data, making decisions, and communicating with the others, all without a human hand guiding them. This isn't science fiction, it's the reality AI makes possible. By equipping swarm drones with advanced algorithms, they can analyze their surroundings, identify obstacles, and even predict potential challenges before they arise. One of the most remarkable aspects of AI in this context is its ability to enable collective decision-making. Unlike traditional drones that operate independently, swarm drones work as a cohesive unit, sharing information and adjusting their actions in real time. For example, if one drone detects a hazardous asteroid field, it instantly relays that data to the rest of the group. The swarm then recalculates its path, ensuring the entire fleet avoids danger. This level of coordination is only possible because of AI's capacity to process vast amounts of data and make split-second decisions. But AI's role doesn't stop at navigation. It also allows swarm drones to learn and adapt over time. Through machine learning, these systems can improve their performance based on past experiences. Imagine a drone encountering a unique deep space phenomenon, perhaps a gravitational anomaly or a rare cosmic event. The AI records this encounter, analyzes it, and uses that knowledge to better handle similar situations in the future. This ability to learn makes swarm drones not just autonomous, but increasingly intelligent with each mission. What truly sets AI-driven swarm drones apart is their efficiency. In deep space, where resources like fuel and power are limited, every decision matters. AI algorithms optimize energy consumption, prioritize tasks, and even predict equipment failures before they happen. This ensures that the swarm operates at peak performance, even in the harshest conditions. The result, a system that's not only capable of surviving the challenges of space exploration, but thriving in them. AI is more than just a tool for swarm drones. It's the foundation that allows them to push the boundaries of what's possible in deep space. By combining autonomy, adaptability, and efficiency, these intelligent systems are redefining how we explore the universe. And as AI technology continues to evolve, so too will the capabilities of these remarkable machines. Deep space is no playground. It's one of the most unforgiving environments humanity has ever dared to explore. Picture this: temperatures that swing from blistering heat to bone-chilling cold in moments, a constant barrage of cosmic radiation, and distances so vast that even light takes years to travel. It's a place where traditional spacecraft, no matter how advanced, often struggle to survive, let alone gather meaningful data. But this is where swarm drones step in, designed not just to endure but to thrive in these extreme conditions. Take radiation, for example. In deep space, there's no protective atmosphere to shield against the relentless onslaught of high-energy particles. For traditional spacecraft, this means heavy shielding, which adds weight and limits mobility. Swarm drones, on the other hand, are built with lightweight, radiation-resistant materials that can absorb or deflect harmful particles without sacrificing agility. This allows them to operate in environments that would cripple other systems, all while staying nimble enough to navigate complex tasks. Then there's the issue of extreme temperatures. In the vacuum of space, heat doesn't dissipate the way it does on Earth, and without sunlight, temperatures can plummet to hundreds of degrees below zero. Swarm drones are equipped with advanced thermal regulation systems. using a combination of reflective surfaces and internal heat redistribution to maintain optimal operating conditions. Whether they're basking in the scorching heat near a star or drifting through the icy void, these systems ensure they stay functional and reliable, and let's not forget the challenge of energy. Deep space missions require power sources that are both long-lasting and efficient. Traditional spacecraft often rely on bulky fuel cells or solar panels, which can be limiting in environments where sunlight is scarce. Swarm drones, however, are designed with energy-efficient systems that maximize power usage. Many utilize compact nuclear batteries or highly efficient solar arrays, allowing them to operate for extended periods without the need for constant refueling. But perhaps the most fascinating aspect is how these drones work together as a collective. In the face of vast distances where communication delays can render traditional mission control impractical, swarm drones are programmed to operate autonomously, making decisions in real time and adapting to challenges as a cohesive unit. This not only reduces the risk of mission failure, but also opens up possibilities for exploring regions of space that were once considered unreachable. So, while deep space presents a host of challenges that would make even the most advanced spacecraft falter, swarm drones are uniquely equipped to face them head-on. Their resilience, efficiency, and ability to work as a team make them the ideal explorers for the final frontier. But as we'll see next, their potential goes far beyond just surviving the harsh conditions. They're poised to revolutionize how we explore and understand the cosmos. Imagine a floating rock tumbling through space, its surface pockmarked with craters and jagged edges. This is an asteroid, a relic of the early solar system, holding secrets about how planets formed and potentially harboring rare metals and minerals. But exploring these irregular, low-gravity objects is no easy task. Traditional spacecraft struggle to land safely or gather comprehensive data. That's where swarm drones come in. These small, autonomous robots can work together like a team of explorers, each contributing to a shared mission. Picture this. One drone maps the asteroid's surface using high-resolution cameras, while another uses lasers to analyze its composition. A third might collect tiny samples, storing them for return to Earth. By dividing the workload, swarm drones can cover more ground, or, in this case, more asteroid than a single spacecraft ever could. What makes swarm drones especially suited for this challenge is their ability to adapt. Asteroids often have unpredictable shapes and weak gravity, which can make navigation tricky. But swarm drones can adjust their flight paths in real time, communicating with each other to avoid collisions or navigate around obstacles. This flexibility allows them to explore areas that would be too risky for larger, more rigid spacecraft. And the potential benefits are enormous. Beyond the scientific discoveries, like clues about the origins of our solar system, asteroids could become a key source of resources. Metals like platinum and rare earth elements, which are scarce on Earth, are abundant in some asteroids. Swarm drones could help identify the most promising targets for future mining missions, paving the way for a new era of space-based industry. This isn't just about technology. It's about expanding our understanding of the universe and unlocking resources that could transform life on Earth. With swarm drones leading the charge, asteroid exploration could become faster, safer, and more efficient, opening doors to discoveries we can't even imagine yet. Imagine a distant world shrouded in mystery where no human has ever set foot. Now picture hundreds of tiny robotic explorers buzzing across its surface, working together to unlock its secrets. This isn't science fiction, it's the future of space exploration, and it's being powered by swarm drones. One of the most thrilling possibilities for these robotic fleets is their ability to search for extraterrestrial life, a mission that could fundamentally change how we understand our place in the universe. Swarm drones offer a unique advantage in this quest. Unlike single rovers, which are limited to one location at a time, a swarm can fan out across vast areas, covering more ground in a fraction of the time. Think of it like this: if a traditional rover is a single detective solving a mystery, a swarm of drones is an entire investigative team, each member working in tandem to piece together the clues. This collaborative approach dramatically increases the odds of finding something extraordinary, whether it's microbial life hiding beneath the surface or chemical traces in the atmosphere that hint at habitable conditions. But how would these drones actually detect signs of life? One key method is through soil analysis. Equipped with advanced sensors, each drone could collect and examine samples from different regions, looking for organic compounds or other indicators of biological activity. Another approach involves atmospheric analysis. Some drones could be designed to fly through the skies of distant moons or planets, scanning for biosignatures, gases like methane or oxygen that could suggest the presence of living organisms. By combining these techniques, swarm drones could paint a comprehensive picture of a world's potential to support life. What makes this even more exciting is the adaptability of swarm technology. If one drone detects something unusual, the entire swarm can redirect its focus to investigate further, creating a dynamic and responsive exploration system. This level of coordination could help scientists prioritize the most promising areas, saving valuable time and resources. Of course, the search for extraterrestrial life is no small task, and swarm drones won't be working alone. They'll be part of a larger mission supported by orbiters, landers, and perhaps even human explorers. But by taking on the role of first responders, swarm drones could pave the way for future discoveries, bringing us closer than ever to answering one of humanity's oldest questions: are we alone in the cosmos? Mapping and surveying alien worlds is no small feat, but swarm drones are poised to revolutionize how we approach this challenge. Picture a fleet of small, autonomous probes working in perfect harmony, sweeping across the surface of a distant planet or moon. Together, they can cover vast areas, capturing high-resolution images, measuring terrain elevations, and even detecting subtle changes in the environment. This collaborative effort allows them to create incredibly detailed 3D maps far more accurate than anything a single rover or satellite could achieve on its own. One of the most exciting applications of this technology lies in identifying geological features that could reveal the secrets of a planet's history. Imagine swarm drones pinpointing ancient riverbeds, volcanic formations, or even signs of past water flow on Mars. These discoveries could provide critical clues about the planet's climate evolution and whether it ever harbored life. And it's not just about Mars. Swarm drones could explore the icy crust of Europa, Jupiter's moon, to map cracks and ridges that might hint at the presence of a subsurface ocean. The possibilities are as vast as the cosmos itself, but the benefits don't stop at scientific discovery. Swarm drones could also play a crucial role in mission planning. By scouting potential landing sites, they ensure future spacecraft touch down safely, avoiding hazardous terrain or unexpected obstacles. This capability could be a game-changer for missions to rocky, uneven surfaces like those found on asteroids or the rugged landscapes of Saturn's moon, Titan. With swarm drones paving the way, we can minimize risks and maximize the chances of mission success. What makes this approach truly remarkable is its scalability. Whether we're exploring a small asteroid or an entire planet, swarm drones can adapt to the task at hand. Their ability to work together, share data in real time, and cover large areas efficiently makes them the ultimate explorers for uncharted territories. As we look to the future, swarm drones could transform our understanding of alien worlds, turning what was once science fiction into a tangible reality. Imagine a future where humanity no longer relies solely on Earth's dwindling resources, but instead taps into the vast wealth of the cosmos. Space mining is no longer the stuff of science fiction. It's a tangible possibility, and swarm drones could be the key to unlocking its potential. These autonomous, interconnected machines are uniquely suited to tackle the challenges of space mining, from prospecting asteroids to extracting and transporting valuable materials back to Earth or other space-based facilities. One of the most exciting aspects of space mining is the abundance of resources waiting to be discovered. Asteroids, for example, are rich in rare metals like platinum and gold, as well as essential elements like water, which can be converted into fuel for spacecraft. But how do we access these resources in the harsh, unpredictable environment of space? That's where swarm drones come in. Unlike traditional mining equipment, which is bulky and limited in its capabilities, swarm drones are lightweight, adaptable, and capable of working together in perfect harmony. They can be deployed to survey an asteroid, identify the most resource-rich areas, and then coordinate to extract and process materials efficiently. Of course, space mining isn't without its challenges. The lack of gravity, extreme temperatures, and vast distances make it a daunting endeavor, but swarm drones are designed to thrive in these conditions. Their ability to communicate and collaborate in real time allows them to adapt to unexpected obstacles, whether it's a sudden shift in terrain or a malfunctioning piece of equipment. Plus, their small size and modular design mean they can be easily repaired or replaced, reducing the risk of mission failure. The potential benefits of space mining are staggering. Not only could it provide access to materials that are scarce on Earth, but it could also enable the construction of infrastructure in space, paving the way for long-term human exploration and even colonization. Swarm drones could play a pivotal role in this vision, acting as the workhorses of a new era of space exploration. By combining cutting-edge technology with innovative approaches to problem-solving, swarm drones are poised to revolutionize how we think about resource extraction, not just on Earth, but across the solar system. Now picture this, a group of drones scattered across the infinite expanse of space, seamlessly working together as if guided by a single mind. This isn't science fiction, it's the reality of swarm drone technology, and at the heart of it lies their extraordinary ability to communicate and coordinate in real time. Unlike traditional drones that operate independently, swarm drones are designed to function as a collective, relying on advanced algorithms and cutting-edge wireless systems to stay connected. So how does this work? At its core, each drone in the swarm is equipped with sensors and communication modules that allow it to send and receive data instantly. These signals could include everything from position updates to environmental readings, enabling the drones to make split-second decisions about their movements and tasks. Think of it like a flock of birds in flight. Each bird adjusts its path based on the actions of those around it, creating a fluid, synchronized pattern. Swarm drones operate on a similar principle, but with the added precision of artificial intelligence and machine learning. The magic lies in the algorithms that govern their behavior. These algorithms are designed to process vast amounts of data in real time, allowing the drones to adapt to changing conditions without human intervention. For example, if one drone detects an obstacle, it can instantly relay that information to the rest of the swarm, prompting them to adjust their trajectory collectively. This level of coordination is critical in deep space, where obstacles like asteroids or radiation fields can appear without warning. But it's not just about avoiding obstacles, it's also about efficiency. By sharing information, swarm drones can divide tasks among themselves based on proximity, battery life, or specialized capabilities. One drone might focus on mapping a celestial body's surface, while another analyzes atmospheric conditions, and yet another prepares to collect samples. Together, they form a highly efficient, self-organizing system that maximizes productivity while minimizing energy consumption. The wireless technology enabling this communication is equally fascinating. In the vacuum of space, traditional radio waves can face challenges like signal degradation over long distances. To overcome this, swarm drones often use advanced communication protocols, such as laser-based systems or mesh networks, where each drone acts as a relay point, ensuring that data travels swiftly and reliably across the swarm. This redundancy is crucial. It means that even if one drone loses connection, the rest of the swarm can continue to function without disruption. What makes this even more impressive is the scalability of swarm systems. Whether it's a small group of 5 drones or a massive network of thousands, the principles of communication and coordination remain the same. This scalability opens up endless possibilities for deep space exploration, from mapping uncharted planets to constructing habitats on distant moons. The ability to operate as a unified, adaptive team makes swarm drones not just tools, but partners in humanity's quest to explore the cosmos. As we continue to push the boundaries of space exploration, the role of swarm drones will only grow more vital. Their ability to communicate and coordinate in real time isn't just a technological achievement, it's a glimpse into the future of how we'll navigate and understand the universe. And with every advancement in this field, we're one step closer to unlocking the mysteries of deep space together. One of the most critical challenges for swarm drones venturing into the vast expanse of deep space is energy. Unlike missions closer to Earth where solar panels can reliably harness sunlight, deep space environments often lack consistent access to solar energy. This limitation pushes engineers to rethink how these drones power themselves over long durations and immense distances. Enter nuclear batteries, a game-changing solution that provides a steady, reliable energy source even in the darkest corners of the cosmos. These batteries, also known as radioisotope thermoelectric generators, convert heat from decaying radioactive materials into electricity, offering a lifeline for swarm drones when sunlight is scarce or non-existent. But nuclear batteries are just one piece of the puzzle. Swarm drones are also equipped with advanced energy harvesting systems that can adapt to the unique conditions of deep space. For instance, some designs incorporate technology to capture and store ambient energy from cosmic radiation or magnetic fields. These systems ensure that even when traditional power sources falter, the drones can continue operating efficiently. The combination of these innovative approaches allows swarm drones to extend their missions far beyond what was previously thought possible, opening up new frontiers for exploration. Energy efficiency is equally crucial. Every movement, every calculation, and every transmission must be optimized to conserve power. Engineers achieve this by designing swarm drones with lightweight materials, low power processors, and algorithms that minimize energy consumption. For example, instead of constantly transmitting data back to Earth, these drones can process information on board and only send critical updates, reducing the energy required for communication. This level of efficiency ensures that swarm drones can sustain themselves over long durations, even in the harshest environments. The implications of these advancements are profound. Imagine a swarm of drones exploring the icy moons of Jupiter or the distant reaches of the Kuiper Belt, powered by cutting-edge energy systems that allow them to operate autonomously for years. This isn't just about keeping the lights on. It's about enabling groundbreaking discoveries in places where humans and traditional spacecraft could never venture. By tackling the energy challenges of deep space, swarm drones are paving the way for a new era of exploration, one where the limits of distance and time no longer hold us back. As humanity sets its sights on the stars and dreams of colonizing distant worlds, one question looms large: How do we prepare these uncharted territories for human life? Enter swarm drones, tiny, intelligent machines that could become the unsung heroes of space colonization. Picture this, a fleet of drones working in perfect harmony, transforming barren alien landscapes into thriving, habitable environments. Their role, to lay the groundwork for humanity's next great leap. One of the most critical tasks these drones could tackle is infrastructure construction. Building on a new planet isn't like assembling a prefab home on Earth. We're talking about creating entire habitats, power systems, and transportation networks from scratch. Swarm drones, equipped with advanced AI and specialized tools, could autonomously survey the terrain, identify optimal building sites, and even assemble structures using local materials. Imagine drones 3D printing shelters or laying down solar panels to harness energy from a distant sun, all before the first human settlers even arrive. But their contributions don't stop at construction. Swarm drones could also act as environmental guardians, continuously monitoring and adjusting conditions to ensure sustainability. For instance, they could track atmospheric changes, detect hazardous chemicals, or even regulate temperature and humidity levels within habitats. This real-time data would be invaluable for maintaining a stable environment, protecting settlers from the unpredictable challenges of space. And let's not forget about resource management. In the harsh reality of space colonization, every drop of water, every ounce of oxygen, and every scrap of material will matter. Swarm drones could be deployed to locate and extract resources, ensuring that settlements remain self-sufficient. They might even assist in growing food, tending to crops in controlled environments to sustain the population. What makes swarm drones truly remarkable is their ability to adapt and collaborate. Unlike single-purpose machines, these drones can work together, sharing data and adjusting their tasks on the fly. If one drone encounters an obstacle, the swarm collectively finds a solution, ensuring that progress never stalls. This level of coordination makes them ideal for the unpredictable challenges of space colonization. So, as we dream of new worlds and the possibilities they hold, swarm drones stand ready to turn those dreams into reality. They're not just tools, they're pioneers, paving the way for humanity's future among the stars. And who knows, one day, the very foundations of our first extraterrestrial cities might bear the fingerprints, or rather, the tiny mechanical hands of these remarkable machines. As we venture deeper into the realm of swarm drone technology for space exploration, one question looms large: how do we ensure this incredible power is used responsibly? The ethical implications of deploying autonomous systems in the vastness of space are as complex as they are critical. Unlike traditional missions where human operators make every decision, swarm drones often rely on artificial intelligence to navigate, analyze, and adapt. This shift raises a fundamental question: what happens when machines are tasked with making decisions that could affect entire missions, or even the future of space exploration itself? One of the most pressing concerns is accountability. If a swarm drone makes a mistake or acts in a way that wasn't intended, who bears the responsibility? Is it the engineers who designed the algorithms, the organizations that deployed the drones, or the technology itself? These questions don't have easy answers, but they force us to think carefully about the boundaries we set for autonomy. After all, space is unpredictable, and even the most advanced AI can encounter situations it wasn't programmed to handle. Another layer of ethical complexity comes from the potential misuse of swarm drone technology. While these systems are designed for exploration and discovery, their capabilities could be repurposed for less noble goals. Imagine a scenario where swarm drones, capable of mapping distant planets with precision, are used to exploit resources without regard for environmental or ethical consequences. This isn't just a hypothetical, it's a real possibility that underscores the need for clear guidelines and international cooperation. And then there's the question of unintended consequences. What if a swarm drone, while exploring an alien world, inadvertently contaminates a pristine environment with Earth-based microorganisms? Or what if its actions disrupt delicate ecosystems we don't yet understand? These scenarios highlight the importance of designing swarm drones with not just efficiency in mind, but also respect for the unknown worlds they're sent to study. Ultimately, the ethical considerations surrounding swarm drones remind us that technology is never neutral. It reflects the values, priorities, and intentions of those who create and use it. As we push the boundaries of what's possible in space exploration, we must also grapple with the weight of our decisions and ensure that the tools we build serve not just our curiosity, but also our commitment to responsible exploration. The future of swarm drone technology is nothing short of extraordinary. Picture this, a fleet of tiny, autonomous drones working together like a well-coordinated hive, venturing into the unexplored depths of space. These aren't just tools for exploration, they're pioneers, capable of transforming how we understand and interact with the universe. The possibilities are as vast as space itself, and the next decade could see breakthroughs that once seemed like science fiction. One of the most exciting prospects is the role swarm drones could play in exploring distant galaxies. Imagine sending a swarm to a far-off star system, where each drone acts as a set of eyes, ears, and hands, collecting data, mapping terrain, and even searching for signs of life. Unlike traditional missions that rely on a single spacecraft, swarm drones offer redundancy. If one drone fails, the others can adapt and continue the mission, ensuring that no opportunity for discovery is lost. But it's not just about exploration. Swarm drones could also revolutionize interstellar travel. Think of them as scouts sent ahead to map safe routes through asteroid fields or to identify potential hazards like radiation zones. They could even assist in constructing infrastructure in space, such as assembling habitats or repairing spacecraft, all while working together in perfect harmony. This collaborative approach could make long-distance space travel more efficient, safer, and far more achievable. Closer to home, swarm drones might also play a crucial role in planetary exploration. On Mars, for example, a swarm could fan out across the surface, analyzing soil samples, searching for water, and even preparing sites for human habitation. Their ability to cover vast areas quickly and share information in real time would dramatically accelerate our understanding of other worlds, paving the way for future human missions. And let's not forget the potential for creativity and innovation. As swarm drone technology advances, we might see entirely new uses emerge, ones we haven't even thought of yet. Perhaps they'll become interstellar artists creating intricate structures in space, or maybe they'll serve as cosmic historians, documenting humanity's journey into the stars. The next decade promises to be a thrilling chapter in the story of swarm drones. As we push the boundaries of what's possible, these tiny marvels of engineering could become our partners in unlocking the mysteries of the universe. The future isn't just bright, it's infinite. What if the future of space exploration isn't about sending one massive spacecraft, but instead deploying a fleet of intelligent, interconnected drones working together like a cosmic orchestra? While swarm drones are still in the experimental phase, some groundbreaking projects are already showing us just how transformative this technology could be. Let's dive into a few real-world examples that are pushing the boundaries of what's possible. One of the most exciting developments comes from NASA, where researchers have been testing swarm drone prototypes designed for planetary exploration. These small, autonomous drones are being developed to work in unison, mapping uncharted terrains on moons and planets. Imagine a swarm of these devices descending onto the surface of Mars, each equipped with specialized sensors to analyze soil, rocks, and atmospheric conditions. By sharing data in real time, they could create a comprehensive picture of the environment far faster than a single rover ever could. It's like having a team of scientists on the ground, but without the limitations of human presence. But NASA isn't the only player in this field. The European Space Agency, or ESA, has been collaborating with international partners to explore how swarm drones could assist in asteroid mining missions. Picture this, a swarm of drones descending onto a small asteroid, each equipped with tools to extract valuable minerals. They communicate with one another to avoid collisions, optimize their paths, and ensure the mission is completed efficiently. This isn't just science fiction, it's a vision that's inching closer to reality with every test flight. And let's not forget about the private sector. Companies like SpaceX and smaller aerospace startups are also investing in swarm drone technology, recognizing its potential to revolutionize space missions. For instance, some are exploring how swarms could be used to repair satellites in orbit, performing delicate tasks that would be too risky or complex for a single robotic arm. These drones could act like a team of cosmic mechanics, extending the lifespan of critical infrastructure in space. What's fascinating about these case studies is how they highlight the versatility of swarm drones. Whether it's mapping alien landscapes, mining asteroids, or fixing satellites, the applications are as varied as they are groundbreaking. And while these projects are still in the testing phase, they offer us a tantalizing glimpse into a future where swarm drones become an indispensable tool in our quest to explore the cosmos. As humanity sets its sights on the stars, one truth becomes increasingly clear. No single nation or organization can tackle the challenges of deep space exploration alone. This is where international collaboration shines, especially in the development of swarm drone technology. By pooling resources, knowledge, and innovation, countries around the world are accelerating progress in ways that would be impossible in isolation. Think of it like a symphony. Each nation brings its unique strengths to the table, creating a harmony that drives the entire field forward. Take, for example, the European Space Agency's partnership with NASA on the Mars Sample Return mission. Here, swarm drones could play a pivotal role in navigating the Martian terrain, collecting samples, and even constructing habitats. By combining Europe's expertise in robotics with America's deep space capabilities, this collaboration exemplifies how shared goals can lead to groundbreaking advancements. Similarly, Japan's contributions in precision engineering and China's strides in swarm intelligence algorithms have opened new doors for global projects. Together, these efforts are redefining what's possible in deep space exploration. But why is collaboration so critical? For starters, swarm drone technology is highly interdisciplinary, requiring expertise in fields like artificial intelligence, aerospace engineering, and materials science. No single country excels in every area, but by working together, nations can fill in each other's gaps. Plus, the financial and logistical demands of space exploration are immense. Sharing the burden not only makes these projects more feasible, but also ensures that breakthroughs benefit humanity as a whole, not just a select few. Looking ahead, the potential for international partnerships is even more exciting. Initiatives like the Artemis Accords are laying the groundwork for a new era of cooperation, where swarm drones could be deployed to map lunar craters, monitor space habitats, or even assist in asteroid mining. And let's not forget the role of private companies, which are increasingly collaborating with governments to push the boundaries of what swarm drones can achieve. From SpaceX's reusable rockets to startups specializing in autonomous systems, the private sector is proving to be a vital partner in this global effort. The beauty of international collaboration lies in its ability to transcend borders and unite people under a common vision. As we venture deeper into space, swarm drones will undoubtedly serve as a testament to what humanity can accomplish when we work together. The stars may be distant, but with shared ambition and cooperation, they're well within our reach. Now, let's zoom in on something that affects us all: the economy. Swarm drones aren't just a leap forward for space exploration. They're poised to make waves in the global economy too. Think about it. Space missions have always been expensive, requiring massive budgets and resources. But swarm drones, they're game changers. By working together in coordinated fleets, they can drastically cut costs, making space exploration more accessible and sustainable. And that's just the beginning. One of the most exciting possibilities is space mining. Imagine a future where swarm drones are deployed to extract valuable resources from asteroids or the moon. These resources, like rare metals and minerals, could fuel industries back on Earth, reducing our reliance on limited terrestrial supplies. It's not science fiction anymore. It's a tangible economic opportunity that could spark entirely new industries. And with swarm drones doing the heavy lifting, the cost of such ventures could drop significantly, opening the door for private companies and smaller nations to join the space race. But the economic ripple effects don't stop there. The development and deployment of swarm drone technology will create jobs, lots of them. Engineers, software developers, robotics specialists, and even new roles we haven't even imagined yet will be in demand. This isn't just about building drones, it's about fostering innovation across multiple sectors. From manufacturing to data analysis, the skills needed to support this technology will drive economic growth and create a thriving ecosystem of opportunities. And let's not forget the technological spillover. The advancements made in swarm drone technology will likely find their way into other industries. Think about autonomous vehicles, precision agriculture, or even disaster response. The same principles that allow drones to work together in space could revolutionize how we solve problems here on Earth. It's a classic example of how investing in one area of innovation can lead to breakthroughs in countless others. So, while swarm drones might seem like a niche topic for space enthusiasts, their impact could be felt far beyond the stars. By making space exploration more affordable and opening up new industries, they have the potential to reshape our economy in ways we're only beginning to understand. The question isn't just what they'll discover in space, it's how they'll transform life back here on Earth. As swarm drones continue to carve out their place in the future of deep space exploration, one of the most critical challenges isn't just the technology itself, it's how the public perceives it. After all, groundbreaking innovations often face skepticism or misunderstanding before they're fully embraced. Think about early reactions to self-driving cars or even the internet. Swarm drones are no different, but here's the thing: public perception can make or break the trajectory of this technology. If people don't understand its potential or its purpose, support could dwindle and progress could stall. That's why education and outreach are absolutely essential. So, how do we bridge the gap between the incredible possibilities of swarm drones and public understanding? It starts with clear, relatable communication. Take, for instance, the concept of swarming behavior itself. For some, the idea of hundreds or even thousands of tiny drones working together might sound like something out of a sci-fi movie, maybe even a little unsettling. But when you explain it in terms of something familiar, like a flock of birds or a school of fish moving in perfect harmony, it suddenly becomes less alien and more awe-inspiring. These analogies help demystify the technology, making it easier for people to grasp its purpose and potential. Of course, it's not just about explaining how swarm drones work, it's also about addressing concerns head-on. Safety, privacy, and ethical considerations are often at the forefront of public discourse, and rightfully so. People want to know what happens if something goes wrong. How do we ensure these drones are used responsibly? Transparency is key here. By openly discussing the safeguards in place, the rigorous testing protocols, and the ethical frameworks guiding development, we can build trust and alleviate fears. But education isn't a one-way street. It's also about listening. Public forums, Q&A sessions, and even interactive demonstrations can create opportunities for dialogue. Imagine a community event where people can see swarm drones in action, ask questions, and share their thoughts. These experiences not only inform but also empower people to feel like they're part of the conversation. When the public is engaged and informed, they're far more likely to support the technology, and that support is crucial for its long-term success. Ultimately, the future of swarm drones isn't just in the hands of scientists and engineers. It's in the hands of everyone who stands to benefit from this innovation. By fostering a culture of openness, curiosity, and collaboration, we can ensure that swarm drones aren't just a technological marvel, they're a shared vision for a brighter, more connected future. Now, let's take a moment to think about how the same swarm drone technology designed for the vast unknowns of space could be a game-changer right here on Earth. Imagine a natural disaster strikes a massive earthquake, a devastating flood, or a raging wildfire. In these critical moments, time is everything, and the ability to quickly assess the situation, locate survivors, and coordinate rescue efforts can mean the difference between life and death. This is where swarm drones could step in, offering a powerful tool for disaster response. Picture this: a fleet of small, agile drones working together as a cohesive unit, capable of navigating through debris, dense smoke, or flooded areas with ease. Unlike traditional methods that rely on human teams or single drones, a swarm can cover vast areas simultaneously, gathering real-time data and identifying survivors faster than ever before. These drones could use advanced sensors and AI to detect heat signatures, listen for cries for help, or even map out safe pathways for rescue teams. The possibilities are as vast as they are life-saving. But it's not just about search and rescue. Swarm drones could also play a critical role in environmental monitoring during and after a disaster. For example, after a hurricane, these drones could assess damage to infrastructure, track the spread of pollutants, or monitor changes in floodwaters. Their ability to communicate and adapt in real time makes them uniquely suited for dynamic, unpredictable environments, something that's all too common in disaster scenarios. And let's not forget their potential in prevention. Swarm drones could be deployed to monitor areas prone to natural disasters, such as earthquake fault lines or wildfire-prone forests. By collecting data on subtle changes in the environment, they could provide early warnings, giving communities precious time to prepare or evacuate. This proactive approach could save countless lives and reduce the overall impact of disasters. What makes this even more exciting is how accessible this technology could become. While initially developed for the high-stakes challenges of space exploration, the principles behind swarm drones, collaboration, adaptability, and resilience are just as valuable here on Earth. As the technology matures and becomes more cost-effective, it could be integrated into emergency response systems worldwide, transforming how we handle crises. So, while the stars may be the ultimate destination for swarm drones, their impact could shine just as brightly right here at home. By adapting this cutting-edge technology for disaster response, we're not just exploring new frontiers, we're also protecting the ones we call home. As we peer into the future of deep space exploration, one thing becomes clear: swarm drones aren't here to replace human ingenuity but to amplify it. Think of them as the ultimate team players in the cosmic arena, robotic partners designed to take on the tasks that are too risky, tedious, or time-consuming for astronauts. By handling these challenges, swarm drones could allow human explorers to focus on what they do best: solving problems, making discoveries, and pushing the boundaries of what's possible. Picture this, a team of astronauts on a distant moon, surrounded by a buzzing network of drones. While the drones map the terrain, collect samples, and scout for hazards, the humans can concentrate on analyzing data, conducting experiments, and making decisions that require creativity and intuition. It's a partnership where each side brings its strengths to the table, machines offering precision and endurance, humans providing adaptability and vision. This synergy isn't just about efficiency, it's about unlocking new possibilities. Imagine a scenario where swarm drones pre-assemble habitats on Mars before humans even arrive, or where they repair critical systems on spacecraft without putting astronauts in harm's way. These aren't just incremental improvements, they're game changers that could redefine how we explore the cosmos. But the real beauty of this collaboration lies in its potential to inspire. When we see humans and machines working together to achieve the extraordinary, it reminds us that the future of exploration isn't about choosing between technology and humanity, it's about combining the best of both. Together, they form a dynamic duo capable of reaching further, learning more, and uncovering the secrets of the universe in ways we've only begun to imagine. So, as we look ahead, the question isn't whether swarm drones will play a role in space exploration. It's how we'll harness their capabilities to empower human explorers. It's a future where the stars aren't just within reach, they're within our grasp thanks to the perfect blend of human ambition and robotic innovation. Scaling swarm drone technology for deep space exploration is no small feat. While the idea of thousands of tiny, coordinated drones working together sounds like something straight out of science fiction, the reality is far more complex. One of the biggest challenges lies in manufacturing these drones at scale. Each unit needs to be incredibly lightweight, energy efficient, and durable enough to withstand the harsh conditions of space, all while remaining cost-effective. Producing such advanced micro-machines in large quantities requires cutting-edge materials and precision engineering, which can drive up costs and complicate supply chains. But manufacturing is just the beginning. Once these drones are built, deploying them in deep space introduces another layer of complexity. Imagine trying to coordinate a swarm of hundreds or even thousands of drones across vast distances, where communication delays can last minutes or even hours. Traditional methods of control simply won't work. Engineers are exploring decentralized algorithms that allow the drones to make decisions autonomously, relying on local data rather than waiting for instructions from Earth. Achieving this level of coordination requires breakthroughs in artificial intelligence and machine learning, pushing the boundaries of what's possible. Energy is another major hurdle. Deep space missions demand drones that can operate for extended periods without refueling. Solar power is an option, but as missions venture farther from the sun, energy becomes scarcer. Some researchers are looking into nuclear-powered drones, while others are experimenting with innovative energy storage solutions. Balancing energy efficiency with the computational power needed for autonomous decision-making is a delicate dance, one that could make or break the success of large-scale swarm missions. And let's not forget about the sheer unpredictability of space. Radiation, micrometeoroids, and extreme temperatures can all wreak havoc on delicate electronics. Designing swarm drones that can adapt to these challenges, or even repair themselves, is a massive engineering challenge. Scientists are exploring self-healing materials and redundant systems to ensure that even if some drones fail, the swarm as a whole can continue its mission. Despite these obstacles, progress is being made. Collaborative efforts between space agencies, private companies, and academic institutions are driving innovation in swarm drone technology. For example, NASA, a research into bio-inspired designs taking cues from nature, like the behavior of bees or birds, is yielding promising results. Meanwhile, advancements in 3D printing are making it easier to produce complex drone components at a lower cost. Every breakthrough brings us one step closer to unlocking the full potential of swarm drones in deep space. The road to scaling this technology is undoubtedly steep, but the rewards could be astronomical. From mapping distant planets to searching for signs of life, swarm drones could revolutionize how we explore the cosmos. And while the challenges are significant, they're not insurmountable. With ingenuity, collaboration, and a bit of perseverance, the dream of deploying swarms of drones across the stars might just become a reality. Swarm drones are more than just a technological marvel, they're a gateway to the stars. With their ability to work together seamlessly, powered by cutting-edge artificial intelligence, these drones are redefining what's possible in space exploration. Imagine a fleet of these tiny explorers, each equipped with specialized tools, venturing into the unknown, mapping distant planets, and uncovering secrets of the universe that have eluded us for centuries. Their collaborative nature allows them to tackle challenges far beyond the reach of traditional spacecraft, making them an indispensable tool for the next era of cosmic discovery. What makes swarm drones truly groundbreaking is their adaptability. In the harsh, unpredictable environment of deep space, their ability to communicate and coordinate in real time ensures that even if one drone fails, the mission continues. This resilience is key to exploring the vast, uncharted territories of our solar system and beyond. From searching for signs of life on distant moons to studying the atmospheres of exoplanets, swarm drones are paving the way for discoveries that could reshape our understanding of the cosmos. As we stand on the brink of this new frontier, it's impossible not to feel a sense of awe and excitement. Swarm drones are not just tools, they're a testament to human ingenuity and our unrelenting desire to explore the unknown. They remind us that the universe is vast, filled with mysteries waiting to be uncovered, and that we are just beginning to scratch the surface. Thank you for joining us on this journey into the future of space exploration. If you're as fascinated by the potential of swarm drones as we are, don't forget to like, subscribe, and share your thoughts in the comments below. The stars are calling, and with swarm drones, we're ready to answer. Together, let's embrace the possibilities of tomorrow and continue pushing the boundaries of what's possible. The future of space exploration is here. Let's explore it together.